Assalamu alaikum everyone. My name is Ghulam Mustafa. I am Statistical Officer, Agriculture Department, Crop Reporting Service, Vehari. Today my talking topic is modeling and forecasting of monthly average maximum surface air temperature in Bhutan using season ARIMA model. Okay, first we talk about outline. First we will talk about the objective, then we talk about time series because our data related to time, then we discuss result, and finally we will go to the conclusion. What is the objective of our study? Our objective of study is to search the best model using the data and develop the forecasting model, and this forecasting model can be used for all relevant departments in Multan district. Okay. Next is the data collection. We have collect the data, monthly temperature, maximum temperature data from meteorology department Multan from January 2002 to December 2021. Because our data related to time series, so we talk about the time series. What is time series? Time series is the chronological order of the time, and for time series we make the different models, and these models can be used for forecasting. As we know that time series has trend and seasonality. What is trend? Trend is the trend may be increase or decrease over the time. Seasonality is the regular pattern, maybe monthly, maybe quarterly, maybe days or weekly. Next important term in time series is our data is stationary or non-stationary. What is stationary? Stationary data mean when our data has mean and variance are constant. When mean and variance are not constant, then our data is non-stationary. For time series analysis, first step is very important is first we check our data is stationary or non-stationary. When our data is non-stationary, first we convert in stationary, then we do next step. How we can detect the stationary? There is two common method. First is the sequence plot method, also called histogram plot, and next is the mathematical model that is called unit root model. Sequence plot. Here is the sequence plot of our data, and we can see there is a no trend because there is a no up and down, but there are peak and down, peak down, but these peak or down are in same way. So we can suggest from here our data maybe have seasonality. Our data has no trend, but our data has seasonality. So seasonality is a problem in our data, and if we remove this seasonality, then we develop the model. Okay, next is the mathematical model. Here is the augmented decay Fuller test. This used, we check the p-value. P-value is less than 5%, so we can say that our data is stationary. Here our null hypothesis is our data is non-stationary, and alternative hypothesis is our data is stationary. Okay, as we know that when our data has a non-stationary, then we convert it stationary for taking the difference. There are two types of difference. First is the regular difference, and second is the seasonal difference. As we see in the previous plot, our data has seasonal difference, so we will take seasonal difference here. Okay, sequence plot after taking the seasonal difference. Here we can see there is a no up and down same way, so seasonal effect have been removed from our data. Okay. Next, because our data has seasonal effect, so most suitable model for our data is a seasonal ARIMA model. ARIMA means auto-regressive moving average model. Here are two parts. First part is related to non-seasonal part and second part is related to the seasonal. What is P? P is the order of non-seasonal AR. What is D? D is difference, regular difference. And Q is the non-seasonal AM, moving average. And P is the order of seasonal AR. Capital D is the order of the seasonal difference. And capital Q is the order of the seasonal MA, moving average model. Here are two parts. First part is related to non-seasonal part and second part is related to the seasonal. What is P? P is the order of non-seasonal AR. What is D? D is difference, regular difference. And Q is the non-seasonal AM, moving average. And P is the order of seasonal AR. Capital D is the order of the seasonal difference. And capital Q is the order of the seasonal MA. Okay, for ARIMA, most popular technique is the box-Jackson methodology. This technique basically has 4 steps. First step is identification, second one is the estimation, third one is the diagnostic, and finally way is the forecasting. Okay. First we go identify our best model. For identifying the best model, we make 2 plots. One is called autoregressive plot and second one is a partial autocorrelation plot. ACF plot is used to identify the order of MA and PAC plot is used to identify the order of AR. These are parallelogram, these are the AR plot and PACF plot. First plot is ACF plot and second one plot is the PACF plot. These plots are taken after the first seasonal difference. Then we plot these 2 plots will be developing. Okay, these 2 plots we can use for building the best model. Which lags are out of these limits? These are used for making the best plot. Okay. Next, we taking different models, comparison model, and we use for comparing different models. We use normalized BIC criteria, and we found that the second one is the best model because he has the ACF and PICF has less than all candidate models. So this model is best model. For declaring this model as the best model, first we check its diagnostic. Then we clear this model is the best model. Okay. Next we move the estimation of this model. Here is the estimate, and its standard error are here. You can see standard error are minimum. Then is the diagnostic checking. Here we are so make the parallelogram. This parallelogram, all the lags are within limits. It means that residual of our best fitted model is follow the normality distribution. Okay. Next we diagnostic checking by the mathematical model, which is called Shapiro-Wilk test. Here we can see that our p-value is less than 5%. So we can say that our data residual follow the normal distribution. Then we use this best fitted model used for making the fitted and second one is the forecasting. Here you can see actual value are denoted by green line, fitted value are denoted by red line, and forecasting value are denoted by green line. We can see that actual or fitted value have a same pattern. It means the accuracy of our model is very best, and we can see also here forecastings have the same pattern like the actual model. It means our forecasting is also better. Now we check the forecasting performance by using other neighbor important model, but we can see here the best model has the forecasting performance has low in both cases. Actually, we have divide our data into two parts. 80% data we have used for building the model, and 20% data we have used for checking the accuracy of the model. These in sample forecasting performance, out of sample forecasting performance, our selected model has these two things are less. In this way, accuracy of our selected model is very best. And then finally we will go to conclusion. So we will select the best Sarima model whose order is 1 0 0 and seasonal part is 1 1 1. Okay, it's the best model, and this model we have used for forecasting 12 months, next 12 months, and this for